All right, in this lesson, we're going to pick up where we left off. We've already started this lesson, actually. When we met last, we were looking for horizontal and vertical asymptotes of rational functions. And your job was to finish these couple of examples from your notes. So I hope you have this out in front of you, as well as a new page to the handout that looks like this. And we'll be picking that up in just a minute. So pause the video if you need to and get all the stuff you need. Let's go through and just check your answers to make sure you're good on these examples before we move on. So let's look at g of x. You were to find an n-model equation so that you could determine the horizontal asymptotes. So by pulling out each of the lead terms from the factors of the numerator and denominator, you should have built the model that y equals, in the end, simplified 2 over 3x, which is our parent function 1 over x with some stretch factor on it. But basically looks like this. And we see that the ends of those on the far right as well as the far left start heading off towards 0 as an output value. So that means our horizontal asymptote is y equals 0. And our h of x function, we build the same n model. Lead terms are x and x squared. So bringing those into an n model equation and simplifying, you should get 1 over x just like before. There's the graph. The ends are headed towards 0, both on the left end and the right end. So our asymptote is y equals 0. And that takes care of the horizontal asymptotes. As far as the vertical asymptotes go, you'll remember we take the denominator and we set it equal to 0, looking for what makes the whole function undefined. So we take this denominator, and I've done that here, let it equal 0, and that produces 2 possible vertical asymptotes. X is -1 and x is 2. I run those in as inputs into the function, and I know the denominator is going to produce a 0, but what does the numerator say? The first numerator, when x is -1 goes in there, does not give me 0. So not 0 as an output over 0 is an indication of a vertical asymptote, and that's going to be at x equals -1. And then I did the same thing with the 2. Plugged in the 2 really into the numerator to see if the numerator would be 0, and it is not 0. The denominator is 0, so there is a vertical asymptote at 2, x equals 2. And then I did the same process on the h of x function. It was one extra step because it didn't come in factored form. And so I put it in factored form and found my zeros to be -3 as well as -1. Moving from there with the test, neither one, well, that's not true. The -3, when it was substituted into the numerator, gave me -3 plus 3, and that is 0. So my numerator is 0 right along with my denominator being 0. That means there was no vertical asymptote. There's actually a hole at x equals -3. And I'm going to come back later in the lesson and we're going to talk about this hole a little bit more. When I did the test for -1, I did not get 0 in the numerator while I did in the denominator, so that did produce a vertical asymptote. So there's just a single vertical asymptote on this problem, x equals -1. Hopefully that worked out well for you. Take a minute if you need to jot down questions that you had about that. And after the lesson, maybe you could ask a neighbor, or if not, if they can't help you, then you certainly should ask me when I get back to class. Okay, so let's move to the second page of your notes. And in this one, we are going to be doing the same. You'll see we're going to find the asymptotes. We're also going to add in the question of finding the intercepts, the X-intercept and the Y-intercept. So I hope you remember the process of doing that from our previous lessons. And then we'll sketch a graph. However, in this lesson, we're not going to do the graphing. In fact, in your assignment, we're going to hold off on the graphing until later on. So our focus today will be intercepts and asymptotes. So let's talk about intercepts. First of all, the intercepts, there are 2 varieties, remember. The X-intercept and the Y-intercept. So if you want to find the X-intercept, you're looking for where the function is equal to 0. And a little lesson on fractions, what would make a fraction equal 0? I know I can't divide by 0, so I can't have 0 in the denominator. That's got to be not 0. But the numerator, if it is 0, what do you get if you take 0 divided by any number that's not 0? Think just 0 divided by 1. That is equal to 0. So finding x-intercepts is a matter of setting the numerator. You want to take your numerator and you want to set it equal to 0 to see what your x-intercepts are. So we'll do that process in just a minute. Finding the y-intercepts. How is that done? Well, the y-intercepts are done by plugging in 0 and seeing what the output is. That's just the usual. So you're going to plug in 0. and find the output. Okay, we will also see that in just a second. Now, asymptotes. This is what we were practicing with our last lesson. For asymptotes, we'll have vertical and we'll have horizontal. Let's talk vertical. So for asymptotes that are vertical, this is where we need to solve and find where the denominator is equal to 0. And then we want to be sure to test. That is not very easy to see. Let me see if I can fix this shadowing. Okay, find where the denominator is 0 and then test it. And the horizontal asymptotes, this is where we need to think about end behavior. So for horizontal, we will build an end behavior model equation. Let me write that this way. We're going to use an end model equation. All right, let's see what we can do with these. Now, these are in factored form. I'm just going to tell you right now, factors are your friends. So you're welcome that I have these factored for you. Each of these, we will take one step at a time. So let's start with X-Intercepts. This is where we're going to take the numerator and set it equal to 0. So I'm going to take my 2x minus 3 and my x minus 1 factors from the numerator, set those equal to 0, and these are going to produce the locations of X-intercepts. All right, so this one's going to be positive 3 over 2, and this will be x is equal to 1. So the X-intercepts are 3/2 and 1. And that finishes that part of the question. Now let me take care of the, I think I'm going to do the vertical asymptotes next, because it's another kind of a similar thing. And so if I want to get the vertical asymptotes, I'm going to do the denominator equal to 0, kind of similar to what I just did with the numerator. Set these factors equal to 0. So I've got vertical asymptotes at x equals -2 and at x equals -3. Now, we better do a test on those to make sure that we aren't getting 0 over 0. So let's go to the original equation and plug in a -2. So if I plug in -2 into this first factor, I'm doing this just in my head here. -2 times 2 is -4 minus 3. So the first factor is -7. And the second factor gives me -2 minus 1, -3. And that's going to be over 0 since I got that from there. So does the numerator produce 0 or is it not 0? Here we see it's not 0 over 0. So I like that this is a vertical asymptote. That's a good answer. And I'd have a similar result if I plug in the -3. You can take the time to do that. -3 in there. The first factor does not make a 0 if x is -3. And neither does the second factor. So this is also a vertical asymptote. I did that pretty quick. I'm going to talk to you later in the lesson about how I actually kind of knew that and boxed those answers right away. Because there are some things about this that you should notice. So we'll look at those in a minute. Let's do the Y stuff. So now the Y-intercept. I'm going to go plug in 0 and find the output. So I just want to know what f at 0 produces. And that means 2 times 0 minus 3 and 0 minus 1 over 0 plus 2 and 0 plus 3. And if you can do some of that in your head, that's great. I'd like you to think that out. So the first factor is just -3. The second factor is -1. And then 2 and 3 down in the denominator. So what does this arithmetic give us? F of 0 is -3 times -1, positive 3 over 6. And if we reduce it, it's 1/2. So we have a Y-intercept. And it is 1/2. Okay, we are getting there. And then finally, this last part of our question is our horizontal asymptotes. So here's where we're going to use an end model equation to find those horizontal asymptotes. Looking at our function and pulling out lead terms from the factors, 2x and x make the lead terms of the numerator. And doing the same in the denominator, x there and x there make the lead terms of the denominator. So simplifying 2x squared over x squared, that's just going to be y equals 2. And that is my horizontal asymptote. Let me make a note here that I did an end model equation. Okay, and the equation is y equals 2. Okay, so that's all of it together, and now I have no room to do a graph, so I'm just going to have to get another piece of paper. We're going to do the graphs next time. Let's walk through those steps again here for the next example. So we're going to find the intercepts, and I'm going to just do the same order, I think. I'm going to do the X-intercepts and the vertical asymptotes. And I like to do those together at the same time because it's all about the x-axis here. This is all the behavior that's I'm going to need to consider when I'm graphing that's on the x-axis. So I like to do those first. So intercepts, I'm looking at the numerator equal to 0 for x-intercepts. So up at the top, we've got two factors of x minus 2 and x plus 4. I want to know when that equals 0. And that occurs when x is 2 and when x is negative 4. My x-intercepts are just those two values, 2 and negative 4. Okay, now let's take the denominator and do the same thing. So here we did the numerator equals 0. Now let's do the denominator equal to 0. So our denominator is x plus 1 squared, and that's 0. This is going to have a multiplicity, and I'm going to make a note of it, just like I do normally for intercepts. Solving that gives x is negative 1. I'm going to note multiplicity is double. We have a repeat factor there. If I plug negative 1 in and do my test, do I get 0 in the numerator as well? I know the denominator is 0, so I'm going to mark that. But what happens in the numerator? So plugging negative 1 in is going to give me negative 1 minus 2. This factor is negative 3. The second factor, let's see what that is. So negative 1 plus 4 is positive 3. When I multiply, do I get 0? No, I get negative 9. So this is not 0 divided by 0. So I do indeed have a vertical asymptote. X equals negative 1, and I'm going to include, it's got double multiplicity. That'll be important for when we graph. Okay, moving on. Now we're going to go look at some y information. What happens when we plug in 0 to our function? Let's figure out our y-intercept. So input a 0 in there. So 0 minus 2. First factor is negative 2. 0 plus 4, second factor is positive 4. Down in the denominator, 0 plus 1 is 1. And we're going to square that. And then we'll do the arithmetic. And this produces negative 8 divided by 1, or just negative 8. All right, so that means that negative 8 is our y-intercept number. All right, the last thing we need to know before we can have all the information for graphing is that end model and how the horizontal asymptotes play out. So let's look at an end model equation. Go grab the lead terms from the factors of the polynomial. On this one, down at the denominator, make sure you get the square on that. So our lead term is x times x in the top, and x duplicity, or multiplicity too, duplicity, x squared in the bottom. This is our equation, y equals x times x over x squared. This is the same thing as y equals 1. And so we have a horizontal asymptote of y equals 1. Label that horizontal asymptote. Okay, so we'll leave that for now. And this is all the information you really need to get a really decent graph of this function. So let's go to the last one. Actually, I think before we go to the last one, I want to talk about one thing. How do I know when I have a horizontal asymptote versus having one of those holes in the graph? In both of these examples, I got non-zero over 0 with all my test points. In fact, I didn't even write it down for this one. I just kind of looked at it and saw it was non-zero over 0 and non-zero over 0. So why did I get that? But looking back a page on our example from the other day, there was an example where we ended up with a hole. This function right here. Our test point, we plugged in and got 0 over 0. Now, why did that happen? I want to make a point about this. So I'd like you to look back at the original function. And notice that this function was not in factored form down in the denominator. And I did that on purpose because I wanted to hide the hole from you at first. But now let's look at this in factored form and see what isn't happening here, or what actually is happening here. So what are the factors of this denominator? Well, they both be x to start off, and then 3 and making a 4 when they add up. I'm going to have x plus 3 and x plus 1. So convince yourself that I'm right about those factors. And then let's bring over the x plus 3 from the numerator. So what's kind of unique happening here? You'll notice this x plus 3 is also a factor of the denominator. It's found both places. And that should answer some questions about why, when I plug in -3 from my test right here, why I ended up getting 0 both in the numerator and in the denominator. Well, that's just because I had the same factor in the numerator and the denominator to produce a 0 in both places. And so when you have this repeat factor, and I think I'm going to highlight this, if I can find a highlighter. When you find the same factor living in the numerator and the denominator, both locations, that is an indication that you have a hole in your graph, okay? This repeated factor that you see in both locations. That means there's a hole at that point x equals -3 that creates that 0 in both locations. So that's why I knew that I would have vertical asymptotes here, because as I looked at the equation, in my mind I was asking myself, do I have the same factor in the numerator that I have in the denominator? And I did not in this case. The factors of the denominator are not the same in the numerator. And the same was true for this last example we saw here. My x plus 1 in the denominator is not in the numerator. So I knew that my solutions to my equation where I set the denominator equal to 0 were not going to give me any kind of weird hole or 0 over 0. So you can think about that as a shortcut, I guess. As you look at this problem right here, do you see a factor in the denominator that also appears in the numerator? If the answer is no, then you really can skip that part of testing your solutions for vertical asymptotes. If you notice that there are no repeat factors in the numerator and the denominator, then you can skip it. It's going to be a vertical asymptote. So I'll kind of summarize that at the end of the lesson again for you and maybe have you write some things down, but let's finish this problem up. Okay, so in the numerator, I'm going to get my X-intercepts. X-intercepts are going to be from where x plus 2 and x plus 1 squared create a 0 output. So my answers for X-intercepts are x equals -2 and x equals -1. And yes, we need to put multiplicity on that one with that repeated factor. And let me list my answers this way. Our X-intercepts are -2 and -1, and double multiplicity that. Okay, so we did the numerator equals 0. Next step is denominator equals 0. So x minus 1 equals 0, and that means x equals 1. And this is a vertical asymptote. And again, I am not going to even test that because I saw the x minus 1 here, but do I have x minus 1 as a factor here? Nope, I do not. So therefore, I know this is going to test out just fine as a vertical asymptote. I'm going to skip that little step, little shortcut for you. Okay, moving on to the y values. Let's see what happens when we plug in a 0 and find our y-intercept. So 0 plus 2, this first factor is 2. 0 plus 1 is 1. Second factor is 1, square that. Down in the denominator, 0 minus 1, that's -1. So if you do the arithmetic to simplify that, g at 0 is an output of -2. So let me say my y-intercept is -2. That'll be a point on my graph. And we finish with the end model equation, which is going to give me any horizontal asymptotes I might have. So as I build my end model, I'm looking at that function. I'm going to take my lead term x. My other lead term is x double multiplicity, so x squared. And in the denominator, x. And put a y equals in front of that. After simplifying, y equals x squared. Y equals x squared. Oh, this is different. Y equals 1 was our answer there, and that was our horizontal asymptote. Y equals x squared, if I think graphically, that's like a parabola, but its ends, are its ends horizontal? No, its ends are going up on both sides. So they don't go to horizontal lines, so this means there is no horizontal asymptote in this function. My ends are not pointing horizontally, they're pointing up. So no horizontal asymptote. All right, so yeah, I think maybe you want to write this down, and probably smart to pause the video so you can get it all down. Let me just talk through it. Here's my tip. The easiest way to deal with all of these functions is to have the factored form. So I took a peek at your assignment, and the functions for the most part are not in factored form. So when they're not, you're going to probably want to take one step and factor your function so that the numerator is in factored form as well as the denominator. You want them to look something like this rather than something like this. If you take that step, then you'll be able to tell when your factors have repeats. It will also be a lot easier for you to solve for the zeros and the intercepts, or the zeros and the asymptotes. Okay, so when you have it in factored form, look at your numerator and your denominator. If they share no common factors at all, so you see a factor in the numerator, but it's not in the denominator or vice versa, then all you got to do is take your numerator equal to 0, and that'll give you X-intercepts. And then do your denominator equal to 0, and that'll give you vertical asymptotes. Okay, so numerator over denominator, just like a fraction. Set the top equal to 0, and you'll find your X-intercepts. Set the bottom equal to 0, and you'll find your vertical asymptotes. If you do see a common factor in both the numerator and the denominator, then you're going to have holes in the graph. So keep that in mind. So for an example, if I had f of x equals x plus 2 and x minus 5, and that was divided by x plus 6 and x minus 5, there's a repeat factor right there. Okay. So that repeat factor is going to produce a 0 over 0. What that means is x minus 5 equals 0, or x is 5 is going to be the location of a hole in the graph. X minus 6 comes from, or x plus 6, sorry. X plus 6 equals 0, that comes from the denominator. So x equals -6. That's from the denominator, that means this is a vertical asymptote. If I got it from the denominator, a vertical asymptote. If I get it from the numerator, x plus 2 equals 0, so x would be -2. If it came from the numerator, then I have an X-intercept at that point, a point on the graph crossing the x-axis. So it just depends on the location that you got the answer from. If it came from the top, X-intercept. If it came from the bottom, it's a vertical asymptote. And if it comes from both, you got a hole in the graph. Hope you find that helpful. Just remember to factor, 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 factor. Okay, there's your tips. You guys have fun with this, help each other out, and I will see you soon.